Remember flipping on the TV and seeing Captain Kirk just casually talk to the computer? Computer, what is the current status of the USS Enterprise?
Oh, yeah, absolutely. That sort of effortless interaction.
That childhood dream. Right, of a computer that truly understood you, your voice, the why behind your words. Our sources actually drop us right into that feeling.
Gene Roddenberry wasn't just imagining a gadget. He was thinking about, well, a real partner.
And that vision, that futuristic idea, it connects directly to what we're digging into today. MTOR.
Exactly. We've got the MTO Welcome to the Realm document, plus some interesting perspectives from AJL and Claude, and they all point to something potentially quite different.
Not just an upgrade, but maybe a whole new way to interact with tech.
That seems to be the core idea, yeah. A fundamentally new approach.
Okay, let's really get into this new way. The document calls MTOR the realm beyond the kernel. So for you, the learner, our goal today is simple.
Well, maybe not simple, but clear.
Okay, fair. Our goal is clear. What is MTOR, really? How does it actually work? And, why should you care? There's so much noise out there.
We want to cut through that. Find those aha moments without getting bogged down in super deep technical weeds.
Think of this as your fast track, a shortcut to understanding something that might be, well, pretty groundbreaking.
And we have this interesting mix of sources, from the big picture philosophy down to some quite specific details.
But the main takeaway right off the bat is that MTOR is just different from the OS you're probably used to.
Very different. Forget your usual mental model of kernels, daemons, all that stuff.
So the big picture, MTOR, this multi-tronic operating realm, it's not built like a typical OS stack.
Right. It's event-driven, it's stateless, we'll get into what that means, and speech is designed as a primary interface.
And that client-server model we all know?
Nope, they call it peer-to-realm, which is interesting.
Okay, so let's unpack that. What really makes MTOR different? The document hammers this point. A realm, not a stack.
Yeah, and that's not just words. It signals a different structure entirely. Think about traditional OS layers, right? Each one relies on the one below it.
Like building blocks.
MTOR tries to break that. The realm idea allows for more dynamic, sort of independent AI components. It's not just renaming, it's rethinking how an AI-focused system is built.
More flexibility, more resilience maybe, especially with AI changing so fast.
Exactly. That seems to be a core driver.
And that leads right into this event-driven by default idea.
Right. So everything inside MTOR communicates using these structured JSON messages.
Everything, like user commands, AI responses, all of it.
All of it. User inputs, worker replies, system status checks, the works. The document calls it a giant programmable AI event router with perfect visibility.
Wow, okay. That paints a picture, like a nervous system where you can see every signal.
Pretty much. Which, has big implications for understanding what's going on, for debugging, for monitoring.
And then the interface, speech is the interface. Back to Star Trek. That computer wake word isn't just nostalgia, it's central. The vision is really natural language interaction.
Getting closer to that partner idea, not just a tool executing commands.
That seems to be the aim, a more fluid, intuitive dialogue.
Now, this next bit might throw people. Stateless by design.
Yeah, this one takes a second to wrap your head around.
So each AI query, each request you send to MTOR, it has to contain all the info needed for that request.
Right. There's no assumed memory or saved state between interactions. They even compare it to CICS, which might ring a bell for some listeners.
Okay, so why do that? Seems less efficient, maybe.
Well, the argument is scalability and resilience. Because each request is self-contained. If one fails, it doesn't mess up others.
Okay. Makes sense in a distributed system with lots of things happening. Easier to manage across different machines, too.
That's the idea. Simpler deployment, less complexity for managing state everywhere. But it's important.
Yes.
While the processing is stateless, they do mention persistent trace logs, so there is a record kept. Right, so it remembers what happened, just doesn't rely on past context for the next action.
Exactly. Stateless in the moment, but with a history.
Okay, now brace yourself for this list. No kernel, no syscalls, no daemons, no file systems.
Yeah. It's like they wiped the OS slate clean.
Seriously, but they didn't just leave holes, right? They have replacements.
They do. So instead of daemons, you have brokers. Instead of file systems, it's more about queries and replies. Instead of syscalls, you have events.
It's a whole different vocabulary, a different way of thinking about computation.
It really is. And it reflects how it manages resources, like no traditional file hierarchy. Instead, MTOR relies on the AI workers themselves to hold or fetch knowledge.
So you ask a question and it queries the right AI model, like summoning info instead of finding a file.
That's a good way to put it. Summoning information, which fits better with how AI works, constantly evolving knowledge.
Okay, so we have this realm. Events, speech, stateless, missing the usual OS bits. How does it actually work? The component.
All right, let's break down the main parts. First, the universal broker.
The intent router, they call it.
Yeah. It takes your voice command, figures out the intent.
Not just the words, but what you mean.
Exactly.
Yeah.
Then it checks which workers are available, sends out the tasks, gathers the results back.
And it handles other stuff too, like the token economy we'll get to, and failovers.
It manages the wallets, handles things if a worker drops offline, throttles requests if needed. It's the central coordinator.
The AI orchestra conductor.
That's a decent analogy, yeah.
Okay, then the AI workers. These do the actual thinking.
They do the heavy lifting, the AI processing, and they can be anywhere.
Like on my machine or somewhere else.
Both. Local, on your land, or remote over the internet. They just need a way to report their health, say what they can do, like, I run this image model, and talk JSON.
And the supported ones. I saw Ollama, Stable Diffusion.
Yeah, Ollama Stable Diffusion 1.5, Elevate for multimodal stuff, proxies for Claude and OpenAI, and importantly, you can plug in custom Python agents too.
So it's extensible, and they just announce themselves.
Pretty much. Self-register, and if they go offline, the system handles it gracefully. No big drama.
Okay, what about safe queue? Sounds like it slows things down.
Hey, not necessarily. It's more about fairness and order. It's described as a real-time intent buffer.
An intent buffer.
Yeah, so it schedules tasks using async methods, handles them first in, first out generally.
Prevents one user hogging everything.
Right, and it does soft throttling if things get overloaded.
Yeah.
Plus, it gives you feedback, like, your request is number 3 in the queue.
Transparency. Okay, that makes sense.
Keeps things orderly and visible.
And the last piece of this core puzzle, health monitoring.
This is the self-healing aspect. The workers constantly report their status.
Like what model they're running, are they okay?
Exactly. Model, status, uptime, latency, even VRAM usage. If a worker fails its health check,
It gets benched.
automatically blacklisted, yeah. Taken out of rotation. And if it recovers later and starts reporting healthy again,
It gets brought back in.
gracefully re-added. The system is constantly taking its own pulse.
That seems pretty crucial for a distributed system like this. Less manual babysitting.
Definitely. It's designed for reliability.
Okay, let's shift gears a bit. Let's talk money, or, well, tokens. The $9,000 token.
Ah, yes, the economic layer. This is a really interesting part of the design.
So it's not just about paying for things.
It is, but the goal seems broader. It's about aligning incentives for everyone participating in the realm.
Like giving people a reason to run workers, maybe contribute models.
Precisely. Imagine researchers getting tokens for valuable models, or you getting tokens for letting your GPU be used. It's trying to build a self-sustaining ecosystem.
That could be huge for open source AI, right? Funding development.
Potentially, yeah. It's a forward-thinking approach to sustainability.
And who manages this token? The RENTAHal Foundation.
Right. And their charter emphasizes things like minimal founder allocation, no special privileges,
Transparent.
transparency in distribution, and crucially, that the token's value is based on its utility within the realm, not just speculation.
Utility-driven value. Okay. So how does the pricing actually work day to day?
They have this dynamic pricing mechanism, also called RENTAHal. It's not fixed.
Like surge pricing for AI?
Kind of, yeah. It fluctuates based on system demand. There's a base cost. And then a dynamic multiplier kicks in based on queue latency, how long the wait is.
So if the system's really busy, it costs more.
Essentially, yes. It's a way to manage demand and allocate resources. If you really need something now, you might pay more. If you can wait, maybe it's cheaper later.
Okay, that's clever. And the token flow itself?
Pretty direct. You, the user, make a request. Your wallet gets debited $9,000 tokens.
And the person running the AI worker that did the job?
Their wallet gets credited the same amount. And the whole thing is recorded on the blockchain.
Simple, transparent. Creates that direct incentive to contribute compute power.
Exactly. Fair compensation for contributing resources.
Okay, stepping back from the mechanics, what about the guiding philosophy? The principles behind MTOR?
Chapter 7 lays out several key ones. First, universal.
Yeah.
One realm designed to run on pretty much any device, anywhere you have Python and a browser. So platform and hardware inclusive.
Imagine that, for you, the learner, the same AI system potentially running on your phone, your laptop, maybe smart devices, that seamlessness.
That's the goal.
Yeah.
breaking down those silos between devices and OSs.
Second principle, open.
Yeah, and this is a strong commitment. It's GPL v3 license.
Which is a pretty strict open source license, right? Requires sharing modification.
It does. And they add this eternal openness clause, explicitly prohibiting closed source forks, patents, secrets.
They really want it to stay open.
Seems so. Fostering collaboration, preventing lock-in.
Third,
Respectful. Focus on privacy and the user's purpose first. Pretty concise, but important.
especially now, yeah. Privacy is huge.
Fourth, decentralized. No central server dependency. Core to the whole idea, sounds like. More resilient, less prone to censorship. That's the argument for decentralization, yes. Distributes power.
Fifth is scalable.
Right. Designed to run locally on one machine, but also scale up to local networks, the cloud, potentially a huge swarm.
So from one user up to planetary scale, that's ambitious.
Very ambitious, but it speaks to the architectural design.
And finally, this idea of built for the people, by the people.
Yeah, emphasizing distributed ownership, open participation, and they also loop back to statelessness here, highlighting it for concurrency and reliability.
It paints a picture of a very democratized AI infrastructure.
Where individuals are empowered, yeah.
So, okay, this all sounds fascinating, potentially revolutionary. But how does someone actually start? How do you, the learner, get your hands dirty?
Right. Chapter 8. You are the sysop now, running your own realm. This is where the dream meets the code, so to speak.
Empowering people to actually run it themselves.
Exactly. Making it practical.
And the steps, are they complicated?
Surprisingly, they seem pretty straightforward, at least to get started. Clone the repo from GitHub. Install the requirements.
Standard developer stuff so far.
Then you launch the broker with a Python command. Connect a GPU node if you have one with another command.
Like Uvicorn something.
Yeah, something like uvicornmain.appallama.
Yeah.
Then you just open your web browser to localhost 5000
Talk to it, computer.
and speak the words. That's the idea. Lowering the barrier to entry.
And this flips the script, right? You're not just a user.
No, you become the builder, the host, the sysup of your own little piece of this realm, a contributor. There's no big central company you're logging into.
It's your realm, that sense of ownership. Big difference from just using a service.
A key part of the decentralized philosophy.
But running your own thing, setup, maintenance, does it handle that itself? Chapter 10 talks about self-configuration and self-healing.
Yeah, this part sounds pretty impressive. A lot of automation designed to make life easier.
Okay, like automatic configuration, what does that mean?
It means when you run it for the very first time, it basically sets itself up, creates the database it needs, defines the worker tables, initializes your wallet.
Starts the web UI, sends an initial message, all automatically.
Apparently so. Zero config deployment, basically, which is great for getting started quickly. Removes a lot of that initial setup headache.
Definitely lowers the barrier. Then there's this config.ini file.
Right. It auto-generates this on the first run. It's designed to be human-readable, easy to understand, and self-documenting.
So you can go in there and tweak things, like where data is stored, which AI workers you prefer.
Exactly. Toggle modules like speech or webcam use, redirect storage path, set preferences.
Yeah.
And if you mess it up or delete it.
It just makes a new default one with comments explaining everything.
That's what it says. Very user-friendly. Acts like a blueprint you can modify.
And the database, it sets that up too. Database bootstrap.
Yeah, it autonomously creates the schema tables for users, sessions, transactions, system metrics, using simple tools like SQLite and Shelf.
No complex database setup required from the user.
Nope. It even populates the initial sysup details and gives you some demo tokens to play with. Manages its own persistence.
And safe fallbacks. What if things go wrong?
It tries to recover gracefully. If your wallet file gets corrupted, it might restore a backup. If the config file is broken, it can revert to defaults.
Updates worker info automatically if it's outdated.
Seems so. The idea is, even if you make a mistake, MTOR tries its best to recover and keep running, a safety net.
Enhances robustness. And the self-healing loop.
It's constantly checking its own configuration. If a setting is missing or invalid, it tries to fix it using default values. Continuous monitoring and repair.
Keeps the realm stable over time.
That's the goal. Adapting and maintaining integrity.
And finally, the watchdog. Sounds serious.
Yeah, the guardian, yeah. Relentlessly checking things like the queue processor, worker health, API accessibility.
And if something's unresponsive,
it tries to restart the component and notifies the sysapp you, like an automated admin, catching problems early.
Wow, okay. A lot of built-in resilience. So you've got your realm running. What about connecting with others, federation in the grid?
Right, Chapter 11. This is where it scales beyond just your own setup. Federation lets different MTOR instances connect and share.
Building a bigger distributed network of intelligence.
That's the vision. Allows realms to collaborate, share resources.
So I could potentially send a task from my local realm to an AI worker running in someone else's realm, maybe in the cloud or on their local network.
Exactly. It talks about how easy it is to connect workers using Uvicorn or an automated fast API agent. Unlocks resource sharing potential.
Expands the capabilities beyond just your own hardware.
And the SysOp interface gives you control over this.
So you can see the remote workers, how tasks are being routed, block certain nodes if needed.
Yeah, provides oversight and management tools for your federated setup. You're still in control of your realm.
And the task routing isn't just random. The broker is smart about it.
It tries to be. Routes tasks based on worker load, latency, the specific model needed.
Finding the best fit.
Finding the best fit, yeah. And it auto-blacklists workers that are consistently failing or slow. Optimizes performance.
Okay, makes sense. Now, for the builders, the developers out there, what's the angle? MTOR is called the first OS for AI native applications.
That's a bold claim, but it highlights the design intent. It's built for AI, not just running AI on top of a traditional OS. Recognizes AI's unique patterns.
So it's designed to orchestrate AI work.
That seems to be the core idea. Makes it potentially very suitable for building AI-powered tools.
And it's API first.
Chapter 14 emphasizes that. Core endpoints like APIChat, Epivision, Apagen, developers can interact via WebSockets or standard REST API calls.
Making it easy to integrate MTOR into other apps or build new things on top.
Yeah, fostering that ecosystem of tools.
And it plays well with others. External APIs, local models.
Seems designed for flexibility. Mentions integrations with Claude, Hugging Face, plus local services like Ollama, Elava, Stable Diffusion.
Model agnostic, giving developers choices.
Right. Leverage the best tool for the job.
Okay, one last crucial area, transparency. How do you see what's going on?
They highlight the built-in debug console in the web GUI.
Not just a log file, but a live dashboard.
Exactly. Showing active connections, workers, query times, queue status, token flow, top tasks, errors.
Yeah.
All in real time. They call it unprecedented transparency.
Wow. That's actually really valuable for debugging, understanding performance. Building trust, even.
Definitely. Seeing is believing, right?
And the main interface also shows queue status, worker health, system load live.
Yep, Chapter 4 mentions that too. Real-time visibility into the guts of the system. Empowers users and sysops.
Okay, so bringing this all home, this deep dive, it really shows MTOR as a fundamentally different beast.
Yeah, a different approach to operating systems truly built for the AI age.
Voice interaction, decentralization, openness at its core.
And those key strengths. Browser native, model agnostic, token governed, extensible, multi-user ready.
It presents this compelling vision for maybe a more intuitive, democratized way to access and use AI.
Could simplify the whole complex landscape of models and infrastructure, potentially.
So for you, the learner, as you digest all this, maybe reflect on the implications. What could an open, decentralized AI realm mean?
How might it change our relationship with technology? Moving from just tools towards something more like intelligent partners.
Definitely food for thought. Maybe even worth checking out the source code, the docs. It raises big questions about the future of computing.
And the role of these open community projects in shaping it.
Indeed. So on that note, we'll leave you with those powerful words from the MTOR document itself. Say it with us.
Computer.
Let the realm begin.